This is 11.2, and we're going to be talking about series. So far we've been talking about sequences, and we said that sequences are just basically a list of numbers that start with a positive integer from n equals 1 all the way to infinity. Okay, this is what we call a sequence. And we saw that they don't necessarily have to start at 1, it can start at 2 or whatever we want, but we have a list of numbers like 1, 3, 5, 7, so on and so forth. This is when n equals 1, n equals 2, so on and so forth. Okay, and we wanted to see, does these list of numbers go to somewhere, some particular number, or do they just diverge? Okay, so that's what we've been talking about so far. And what we're going to be looking at now is just these series, which we're going to call first partial sums. So basically what a partial sum is, I'm just basically adding all of these sequences together. So if I take the sum of the first number, well, it's just going to be a1. That's the first term. If I take the sum s2, s2 is the sum of the first two terms, a1 and a2. s3 is going to be the sum of the first three terms, a1, a2, and a3. All the way until I get to the nth term, which is going to be a1 plus a2 plus a3, all the way until I get to the last an term. Okay, now usually there's some shorthand notation that we've learned in pre-calculus, and that's just equal to the summation from I goes from 1 to n of a sub I. And this is just really fancy notation that basically just says that I goes from 1, so it's starting at 1, all the way to n. That's where we're going to end, and we're going to add all of these AIs. Okay, so we've seen the summation notation before. So basically what I've done, notice that all of these S's are now a new sequence. So I just created a new sequence for myself. Okay, and this sequence is just S sub n from n goes from 1 all the way to infinity. Okay, so I made myself a new sequence. Oh, it can be infinity or it can be whatever. Okay, so I created myself a new, especially if n was going all the way to infinity. So this is kind of what I really want to be able to look at. So be able to sum up all of these different types of sequences and seeing if this actually goes somewhere. Okay, so this brings us to infinite series. Okay, so what infinite series are, you're basically summing up from 1 all the way to infinity all of the different sequences, which is basically the same thing as taking the limit as n goes to infinity of s sub n. Okay, so s sub n is a sequence of all these numbers, and if you take the limit of the sum, then you will be able to figure out whether the sum of the sequences converge or not. And again, if this exists and it's finite, okay, so if it's a number, then we call it convergent. Okay, however, if it does not exist, or you get positive infinity or negative infinity, then we say this is divergent. So very similar to sequences. Okay, so usually what we're going to be doing, we're probably going to do a couple problems with this part, this guy right here, a couple problems, but the majority of chapter 11, we're mainly going to be looking at this. Because sometimes some of the sequences is really difficult for us to kind of have a formula for the partial sums. It's really, really difficult. There's some problems that have it, which you'll see right now. But usually a lot of the times, it's really, really difficult to use this particular definition. Usually we want to be able to work with a summation and then try to figure out what test would be useful. So let's start off with this problem. Okay, example. Okay, does the summation from n goes from 1 to infinity of 2n converge or diverge? Okay, that's what I want to figure out. Does this converge or does it diverge? Okay, now without doing anything, you can kind of just imagine that this, by trial and error, that this is going to converge because, I'm sorry, that this is going to diverge because if you keep adding, so if I plug in n equals 1, take n equals 1, well, that's just going to be plugging in that, you're going to get a 2. Plug in n equals 2, plug in that, you're going to get a 4. n equals 3, plug in that, you're going to get a 6. Okay, n equals 4, plug in that, you're going to get an 8. So you see that you have all of these numbers, you're going to add all of these guys up. Obviously, if I keep adding these numbers that are getting bigger and bigger and bigger, this is going to go to infinity. So even by trial and error, okay, if I were to just look at this intuitively, you know that this is going to diverge. Okay, now how can we possibly do it with a partial sum? Well, a sub n in this case is going to be equal to 2n, okay, because that's what this guy is, 2n. All right, so what we want to figure out is, can we figure out a formula for the sums? Well, if you remember from pre-calculus, this is just an arithmetic sequence. Okay, and if you remember the formula for these guys, you just have S sub n is equal to n over 2 a1 plus an, which clearly hardly anyone remembers, except maybe me, okay? But this is basically how you would figure out what this what the sum would be. So all you have to do is plug everything in there. When I plug in a1 is the first term, which is just 2. So you're going to have n over 2. Then you're going to have 2 plus an is just equal to 2n. This is going to give me, if I distribute the 2, you're going to have n and then 1 plus n, which gives me n plus n squared. Okay, so this is equal to s sub n. So all I have to do is take the limit of s sub n. So I'm going to take the limit as n goes to infinity of s sub n, which is equal to the limit as n goes to infinity of n plus n squared. Notice that if I were to plug in infinity, you're just going to get infinity anyways. Okay, so see how doing it by trial and error was probably easier to look at, okay, because you immediately plug it in and you're like, okay, well, this is dumb. I'm just going to add all these numbers. They're going to get really big, so it diverges, okay? And if you do it the second part, well, some of you guys maybe have forgotten these formulas, okay? So about the arithmetic sequence. But it's still nice to be able to know it, be able to plug it in and show by the limit definition that it equals infinity. So what can we do, especially if we forgot all of these formulas, or maybe plugging it in is not obvious, because sometimes when you look at the summation, it might not be very obvious whether this is going to converge or diverge. So what you want to do instead, you want to come up with a couple tests that are going to be able to help you figure out whether this converges or diverges. And one of the tests, the first test that you're going to learn here, is what we call the test for divergence. Okay, so here is the first test. So this says that if the limit as n goes to infinity of a sub n does not exist, or if the limit as n goes to infinity of a sub n is not equal to 0, then the series, the sum from n goes from 1 to infinity of a sub n is divergent. Okay, so that's what the test for divergence says. So here's your first test. So if you take the limit as a sub n and it either does not exist or gives you something that's not equal to 0, then the series, this sum, is divergent automatically. Okay, as long as you can show that, then you know that it's divergent. Okay, if the limit as n goes to infinity of a sub n equals to 0, then we don't know. Okay, so we have to do something else. We don't know. You just don't say, oh, I don't know. Okay, we have to do some other tests. So for right now, we're only going to learn one test. Then later on, I'm going to show you more different types of tests to kind of figure it out. But this is basically what we have. Okay, so let's do a couple of examples. Okay, using the divergence test. Okay, so example. Okay, determine if the series converges or diverges. Okay, so here's my first problem. The sum from n goes from 1 to infinity of 3n minus 2 divided by 4n plus 1. Okay, so does this converge or diverge? Well, the first thing to kind of notice is that you kind of don't want to be able to plug in numbers, kind of how we did in the previous problem. You don't just want to plug them in because then when you add them all up, you're not quite sure if it's getting bigger or maybe there might be a maximum. You're not quite sure, so do not plug them in. You want to be able to do something that will be helpful. Okay, so you don't want to plug them in. This is definitely not an arithmetic sequence, so we don't even know what the formula would be for the sum, so we can't even do the second part either. So what should we do instead? Well, we just learned this neat test for divergence, and all we got to prove is that either the limit doesn't exist or it's not equal to 0. Okay, so we're going to take this term right here. Okay, I'm going to maybe put it in a different color. Okay, I'm going to put this thing right here, and I'm going to take the limit of it. Okay, so we're going to use a test for divergence. Okay, I'm going to write test for divergence or divergence test, whatever you want to call it. So what I'm going to do, I'm going to take the limit as n goes to infinity, and I'm going to take it of 3n minus 2 divided by 4n plus 1. Okay, so let's see what this gives me. So let me use L'Hopital's rule. So I'm going to get the limit as n goes to infinity of the derivative of the top and the bottom is going to give me 3/4, which is going to give me 3/4. Okay, cool. This number is not equal to 0, which is basically what we needed. It's not equal to 0. If it's not equal to 0, what does it say? The series diverges. So what can you say? By the divergence theorem, or by the test for divergence, not the divergence theorem. The divergence theorem is something else. By the test for divergence, the sum from n equals 1 to infinity of 3n minus 2 over 4n plus 1 diverges. Okay, you have to write this. Okay, don't just say diverges. Just say by what test did you use? You use a test for divergence, so this is what you're going to say. It diverges. Okay, alrighty. Okay, so let's try one more problem. Okay, the sum from n goes from 1 to infinity, okay, of 4n squared divided by n plus 1. Okay, so what do you think this should be? Okay, so let's go ahead and use the test for divergence. Okay, so we're going to take the limit as n goes to infinity of this a sub n, 4n squared over n plus 1. We're going to use L'Hopital's rule again. So limit as n goes to infinity, the top part is going to be 8n divided by 1. So you're going to have the limit as n goes to infinity of 8n. This is just going to give me infinity. Infinity is not equal to 0. So by the test for divergence, the sum from n goes from 1 to infinity of 4n squared over n plus 1 diverges. Okay, and that's all there is to it. Now, if it equals 0, we don't know. We don't say that it converges because we're not sure. We have to show that it actually doesn't, converges or diverges as well. So in the next video, I'm going to show you 2 different ways that you can try to figure it out. And if you can't, then you have to use some other type of test.